Understanding recursion.
Recursion is a programming technique where a function calls itself to solve smaller instances of a problem. It is often used for tasks that can be broken down into similar subproblems, such as tree traversal or factorial calculation. Recognizing when recursion suits a problem is a vital skill for writing clear and efficient code.
Advantages of recursion.
Recursion can make code more elegant and easier to understand, especially for problems with naturally recursive structure, like exploring data trees or performing divide and conquer tasks. It helps reduce code complexity and can eliminate the need for explicit loops, making the logic simpler and closer to the problem's mathematical definition.
Drawbacks of recursion.
Despite its benefits, recursion has some downsides. Each function call consumes stack memory, which can lead to stack overflow for deep recursions. Recursion may also be less efficient than iterative solutions in some cases, due to overhead from repeated function calls and lack of explicit control over execution.
When to use recursion.
Use recursion when a problem is naturally self-referential or can be divided into similar subproblems, like sorting algorithms, quicksort, mergeasort, tree and graph traversals, and combinatorial problems. If an iterative solution becomes too complex or unreadable, recursion may provide a clearer and more manageable approach.
Best practices for recursive code.
To write effective recursive functions, always ensure you have a base case that stops the recursion. Avoid unnecessary repeated computations by using memoization if possible. Consider the function's memory footprint and rewrite as an iterative version if recursion may cause stack overflows, especially for large inputs.